Okay, so the topic for this tiny little unit here is called recursion. Okay, so recursion is not necessarily a new topic in the sense that it's not going to add necessarily stuff to your programming that you can't already do. It's an alternative way of programming. Okay, so let's start with this. How many of you know what this means in math? Anyone? What's it called? Factorial. Yeah, that's called a factorial. And it's just a shorthand way of writing something in math. How do you write 5 factorial in math? Do you know? That's right. 5 times 4 times 3 times 2 times 1. That's what a factorial means in math. It just is a way of expressing something mathematically in that way. But if that's the case, what's 4 factorial? Well, it's 4 times 3 times 2 times 1. Right, that's 4 factorial. But I want to show you something. That means 4 factorial, which you can see right there, is the same as this. Notice how that's the same? So in other words, another way we could have written 5 factorial is 5 times 4 factorial. It would have meant the same thing, right? Because that's what 4 factorial is, and so therefore it fits into the equation. So then another way, let's see if you guys can get this. What's another way I can write 4 factorial? Anyone think of it? I mean, look at the way I wrote 5 factorial. It would be close, 4 times 3 factorial. Now this is mathematics, right, where you're using these types of expressions. But recursion, in a way, relates to this. It is something that recurs within itself. Okay, so I'm going to give you a presentation on that. Whoops. Real quick. It's a very short presentation today. Okay, so this idea of recursion is the root of the word recur, which is a computer program that uses itself within itself. Okay? More specifically, what we're talking about here is methods. The technical term for recursion is a method that calls itself. Okay? Now, for some students, recursion is the easiest concept you're ever going to learn. For others, it is very tricky to get a grasp on. It's kind of one of those things where either you get it or you don't. But let's take sort of an unrealistic example. Let's say I had a dictionary out, and I asked you to look up a word. Let's say the word was superstitious. So you're going to look up the word superstitious in a dictionary. So the second you find superstitious and you start looking and start reading its definition, let's say you find a word in there that you don't understand. So you start reading the definition, it says a supernatural. Oh, I don't know what that word means. You could stick a sticky note on the page where you were looking up superstitious, then go look up supernatural. And then you'd start reading the definition of supernatural. And let's say there came across a word in there that you didn't understand. Well, you'd do the same thing. You'd put a sticky note on the page for supernatural, and you'd go look up that word, etc. Eventually, you'd get through the definition, and you'd know what that word means. Then you'd go back to the sticky note where you were before, and then you'd go back again to eventually finish looking up the actual word you started with. Seems like a simple way to look something up in an old book dictionary. But that's essentially what recursion means. It means you are sort of doing something within itself. Okay? So here's the way you could look at that in pseudocode. Here's a method called lookup. Again, this isn't real code. I'm going to look up a word. And it doesn't matter what this code looks like. What matters is that this method called lookup calls itself within the method. And this is a bit of a weird syntax, to have a method that's calling itself. And that's what recursion essentially is. It is a method that calls itself. Okay, this technique of using recursion will allow you to take problem solving and subdivide it into smaller categories. You have to know what methods are for this to work. But that's what recursion does, is it divides itself up into methods that call themselves. Recursion is part of pretty much every single programming language, okay? From Java to C# through C++, they all implement some form of recursion, okay? So you may see me use the word function here, which is the same as method. But that would be, again, a recursive function would be a function that calls itself, which kind of relates, again, back to math. So this, again, this idea, and I'll show you back right here, is that's what we have mathematically. This is a math function, 5 factorial. And that math function calls itself. Let me give you another one, maybe a simpler example. What's 2 to the power of 3? Well, you probably know that that's really 2 times 2 times 2. That's what 2 to the power of 3 means. But what's another way I could write this? I could write that as 2 squared, right? So another way I can write 2 to the power of 3 is 2 times 2 squared. So it's very similar to factorial. But let me go a step beyond. What if I have 2 to the power of n, an unknown value? What would it be? Well, it would be, just looking at what I had above, it would be 2 times 2, but what would be its power? How does this number relate to that number? 1 less, actually, n minus 1. That's how I could define powers. And it doesn't have to be a 2 either. It can be any number to the power of n equals that same number times, no, that's probably not a bad, to use a different symbol here, times that same number to the power of n minus 1. That's a way I could define powers recursively. It's also a way I could have defined factorials. Any number, n factorial, equals n times n minus 1 factorial. That's what it means. It is a method or a function that defines itself in terms of itself. Okay? Whoops. Okay, so let's do this through an example. So let's launch NetBeans. Do a real quick example of this. We'll do the factorial example. There it is. Okay, so launch NetBeans, and we'll get going with this. The concept behind recursion is simple, but when you actually write code to implement it, this is where it gets a bit tricky. And I actually want to use this example right here. How do we get this to work? Well, it works because of special incidences that are really going to be the way we do this. Hopefully you guys, through your 11 or 12 years of math education, know what the answer to this question is. What's 2 to the power of 1? 2. Okay? Now, 2 squared, I'll give you the answer, is 4. But here's another one. What's 2 to the power of 0? Right. It's 1. And really, does it have to be 2? No. Anything to the power of 0 is 1. And also, how would that work for this one? Anything to the power of 1 is, or x to the power of 1 is x. That's right. You guys have just identified 2 important incidences that are going to make this work. Those two incidences are what are known as base cases. They are sort of exception cases. They are the exception to the rule. Anything to the power of n is that thing times anything to the power of n minus 1. Those are the two exceptions to that rule. And those are known as the base cases. Okay, so let's write some code for this. So I'm just going to make a quick project, recursion example. Okay, so let's get started with this. So we're going to write some code just inside a main. Very simple. Okay, let's make an integer called number. Let's set it to 10. Let's make an integer called answer. We're going to get the answer. And the answer is going to be derived from a method we're going to write called factorial. We're going to derive what is the factorial of our number. Actually, let's not make it 10. That's a bit high. Let's make it 5. So it's exactly the example I used on the projector. What's 5 factorial? Hopefully, it will give us an answer. So let's output what the answer is. So the answer is answer. Okay? So this is going to be a method. We're going to write a method called factorial that's going to take our number as a parameter, and it's going to calculate the answer. We're then going to take that answer and output it to the screen. That's what we want to do. So we want to write this method called factorial. Now, again, this is a bit of a review, but you may recall that when you're using methods in Java, if you want, NetBeans can help you write that method using that light bulb right there, if you want. And I'm going to use the light bulb. I'm going to create the method called factorial. It's going to pop down here. Okay, this is not going to be a lot of code. It's going to be very little amount of code. But let's say, instead of 5, I ask for the factorial of 1. In other words, what's 1 factorial? Now remember, what you guys have already figured out, that any number to a factorial equals that number times that number minus 1 factorial. So how would that apply for 1? 1 would be equal to 1 times 1 minus 1 factorial. Well, what's this, 1 minus 1 factorial? Well, 1 minus 1 is 0. So what's 0 factorial? It would be equal to 0 minus 0 minus 1 factorial, which becomes negative 1. And it would just, the problem with this is, what you can imagine is it's going to go on forever. That'll keep getting smaller and smaller and smaller and smaller and smaller forever. So the problem with this thing called recursion is we need a way to stop it. Very much like a loop, recursion works by doing something over and over again. But we need a way to stop it from occurring. We stop it using that thing called the base case. And there may be more than one of them. So I'm going to say base cases. And this is one of those incidences. 1 factorial is just 1. That's it. 1 factorial is 1. We don't need to do some fancy formula for it. So let's use that within our method down here. Let's say, well, if the number equals a 1, let's return 1. Okay? So if I pass this method a 1, I just say, you know what, the factorial 1 is 1. I return it. It's real easy. And actually, that works for other numbers as well. else if the number equals 0. What do you think the factorial of 0 is? 0. So we'll return 0. Now, technically, in our program, we're not going to worry about negative numbers. We're just going to stay with positive numbers. But I just want to ask, can any of you think of a way to optimize that code? Instead of having an if and an else if, could we reduce that code down? Is there a way we could write better code than that? Yeah, absolutely you could, right? So why not just write it as else if number is, as just said, less than or equal to 1, return the number, which would not only work for now 1, it would also work for 0. So if I send it a 0, 0 is less than 1, it would return 0. If I send it a 1, 1 is less than or equal to 1, it will return 1. And now it'll also account for negative numbers. But it won't try and do any math with it. So if I give it -5, it'll return -5. And that's fine. But now we have an else. For the else, we now need to apply our formula. And so here's how it goes. We return the number times the factorial of the number minus 1. And that is it. That's the whole method. And because this method only has one line, I'm actually going to optimize it slightly by taking out some of the curly brackets. Remember, if you only have one line of code, you don't need the curly brackets. And if you only have one line of code, you can actually move the code up to the same line as the if statement itself. And believe it or not, that's it. That's the whole method. If the number is less than or equal to 1, return the number. Else, return the number times the factorial of the number minus 1. Let's try this with a little example. Let's say I give it the number 3 right here. Say I pass it a 3. It'll say, is 3 less than or equal to 1? No. So it'll return 3 times, and then right here, it stops. Because what I'm doing now is I'm making a second method call. So it stops right there and waits for the result of that method call. Well, so then it would call it again. This time, it would go the factorial of 3 minus 1, so 2. So now it's doing it all over again. It says, well, is 2 less than or equal to 1? No. So return 2 times the factorial of 2 minus 1, which is 1. Which means it stops right there, and it calls another method. What's the factorial of 1? Now when it calls this, it hits my base case. Is 1 less than or equal to 1? Yes. So this will now return the answer 1. So now this is substituted with a 1. 2 times 1, this will be now completed, and it will return a 2. 2 times 3 will now be finished, and this thing will be finished, and it will return the answer 6 as the final answer. So recursion is a bit tricky how it works, but its code itself is incredibly simple. So we've asked, or we're going to ask, for the factorial of 5. And let's go all the way back to where I started this today, right here. Who can figure out what the answer to this is? What is the factorial of 5? Well, what's 5 times 4? Come on, let's do some mental math. 5 times 4 is 20. Times 3, 60. Times 2, 120. Times 1 should be 120. 5 factorial should be 120. So if we try and run this, we know what the answer should be. So I'm going to run it and hope for the best. Okay, the code is simple. It's clean. It's very simple to look at. And there it is. The answer is 120. The code is simple and clean with recursion. but it needs something specific. So I'm just going to break this up into 2 lines again, and I'm going to put a comment here. This is what's called our base case. And down here, this is called the recursive case. And you can have one or more base cases or one or more recursive cases in every method that's recursive. Okay, let's try one more quick example. In the same example, let's make an exponent equal to 3. So now we're going to do the power thing. We're going to say answer equals the power of our number raised to our exponent. And then we'll spit out the answer again. So I'm just going to repeat that line of code. Okay, so we're now going to use a different method here called power. We're going to write this method. And what it's going to do is it's going to take 5 and raise it to the power of 3. What's 5 to the power of 3? You guys should be able to mentally calculate that. Sure, 125, yeah. 5 times 5 times 5. So that's what we should get as our answer here. But we're going to use recursion to write this method called power. So let's use our light bulb, and let's create the method called power. And it threw it down here, so I'm just going to move it up so you guys can see it. Okay. Luckily, whenever you use nice names, when you make a method, it'll carry those nice names over to the method itself, which makes sense. That looks good. Number to exponent. Okay, so we need a base case or base cases, and we need a recursive case or cases. Base cases always go first because that's what stops the recursion. Is what's the special case that I'm going to stop this recursion from occurring at? Now let's take a look back at our board notes here. What were the special case or cases when I was raising something to a power where I didn't have to do a fancy formula? They're in the top corner. When it's either a 1 or a 0. And in both cases it's different, right? It's not like factorial. When it's raised to the power of 0, I return a 1. And when it's raised to the power of 1, I return itself. So let's take care of the base cases. If exponent equals 0, I return 1. Right? Anything to the power of 0 is 1. Else, if exponent equals 1, what do I return? Who can think of the answer right there? Number, that's right. I return number. So those are my base cases. That's what stops the recursion. But now I have the else. And now I go back to my board notes. What was the formula for, well, it's right here. The number to the exponent equals the number times, and you can maybe see the way it's going to go. It is, I return the number times the power of the number, comma, to the exponent minus 1. And that is it. That's the recursive case. Okay, let me just clean the code up a little bit here. And there's, sure, you could use curly brackets. There's lots of ways you could write this. I'm just quickly throwing this out just so it's a way to take a look at this. But that's really it. That's now how I can take power and do it recursively. The alternative to doing things recursively would be to write a loop. You could certainly do the same two methods using a loop. What recursion offers you is another tool in your programming toolbox. It's not necessarily going to be the tool to solve it. But let's see if it works. Let's see, by the way, I never actually ran that code. Let's make sure power works. And look at that, it worked. I have the factorial and I have the power in one problem using recursion. Okay, in the notes I have that example, so you can certainly look it up in my notes if you want. Come on. It talks about factorials in my notes. I'm not going to go through that now because we've just done it. It does show the alternative way you could write it using a loop, or often known as the iterative method, okay, which is the loop-based method. And one isn't necessarily better than the other. It's just an alternative to your programming. In some problems, recursion is the better way to write it. In other problems, it is not the better way. You should use something like a loop. Okay? But again, as it says in the notes, you need one or more base cases and one or more recursive cases for a recursive method to work. Okay? So then it shows how factorials work using recursion, and then it writes the recursive function factorial or factorial. Okay? They both produce essentially the same results. Whether it's a loop or recursion, you're going to get the same answer. But recursion sometimes gives you shorter code. It sometimes gives you simpler looking code. But it doesn't always necessarily give you more efficient code. Believe it or not, recursion often eats up more memory than a loop. Sometimes. So again, you have to analyze what kind of problem solving you're doing with your programming. It's another tool in your programming toolbox. And that's it.